Good morning, children. Today we are here to discuss Unit 8 Floating Bodies of 9th class. Within this particular class, today we are going to study about one principle. That principle is called as Archimedes principle. Based upon this particular principle, we are going to perform an activity called as Activity-9, which gives information about measuring the weight of water displaced by immersed stone. When a stone is immersed in water, what happens is measuring that particular weight of that particular water displaced outside. Water will be coming outside through a beak into another jar, that is what? Measuring jar. That collection now we are going to perform that activity after studying what is meant by Archimedes principle and its formula. Coming to Archimedes principle, what is called as Archimedes principle? If I go for when a body is immersed in a fluid, I have taken a beaker. In a beaker I have taken in water there. And water I have taken and I have allowed a body, an object to be immersed in this particular liquid. As a body is immersed in the liquid, what happens there? Upward force will be acting upon the body. That upward force is nothing but what? Force of buoyancy, which is also called as upward force. Simultaneously, what happens there from the center of this particular object? Gravity force, gravitational force, gravitational pull of an object will be taken place in downward direction. One force will be acting in downward direction, another force will be acting in upward direction. When this body is immersed in this particular liquid, some portion of water will be displaced outside. If I am taking a beaker here there. If I am taking a measuring jar, from this, depending upon the weight of this particular object, what happens there? Water will be collected in the beaker. The water will be displaced outside depending upon the immersed portion of this particular object. That particular phenomena is called as what? Archimedes principle. It is called as what principle? Archimedes principle. This Archimedes principle can be formed upon one force, that is nothing but what? Force of buoyancy is equal to Rho into G into V. Whereas Rho is called, Fp is nothing but what? Buoyancy force, we can call it a Rho is called as what? Density of fluid. If I have to depending upon the water here, depending upon the liquid, what else I am taking in this particular beaker? Either if I am taking water, it is 1 gram per cubic centimeter. If I take any other liquid other than of water, then what happens? We can get the density of the particular concerned liquid. So that I have taken in the form of fluid here. Rho indicates density of fluid, where G indicates acceleration due to gravity of the body there, whereas V indicates volume of fluid displayed. The volume, which is the water which is displacing outside. If I calculate its volume of liquid, how this particular water displays? By immersing of this, by submerged of this particular object. As the object is submerged in the water, what happens? The liquid is displaced outside. The volume, we can calculate the volume of this particular displaced liquid, that is nothing but what V. By using this particular point, Archimedes formula, we can calculate what? Buoyancy force or force of buoyancy, that is buoyant force can be calculated. This is Archimedes principle. Coming to what? Activity 9. What is activity 9? For what purpose we are doing this activity 9? This activity 9 is used to measure the weight of water displaced. We are going to calculate weight of the water displaced when stone is immersed in water. When stone is immersed in water, how can we measure the weight of a particular water displaced? To perform this activity, we require what? Spring balance is required. Then afterwards, stone is required, and overflow jar is required. Measuring jar is required. These all are the requirement of material to perform this particular activity. What are things? Spring balance, stone, water, overflow beaker, as well as measuring jar. Here this overflow beaker consisting of a beak. Then afterwards, what you do? First you take a stone. Take the stone in such a way that whose weight is greater than 300 grams. Whose weight is greater than 300 grams or more than 300 grams. 300 grams, the stone must be existed. Take such type of stones and tie it to the hook of this particular spring balance and measure its weight before immersing into the liquid. Note down its weight is equal to how many grams? W1 grams, you calculate it up. Later on, what you do? Take this particular beaker, fill it with water up to the overflow of this particular point, such that as you are filling up, complete this particular point exactly, such that the drops from this particular beaker can be get outside. Up to the overflow of a particular level, we have to fill it with what? Water. And after drops have been get completely, if drops are after falling of all the drops, when the liquid is not falling, at the time place a measuring jar at the bottom of this particular beaker. Then what you do? Immerse this particular stone into the water. As soon as we are immersing this particular stone into the water, what happens there? Depending upon the weight of this particular stone, the water level gradually rises up. As the water level gradually rises up, what happens? Through this particular beak, the water will be deposited in this particular beaker. The water will be displaced from this particular beaker, overflow beaker to the measuring jar. The water will be displaced depending upon the weight, and identify its weight be as what? W2 grams, you take it up. If you want to put differences between these two weights, what we can get? W1 gram minus W2 grams. If I calculate how much weight the body has lost, apparent loss of weight of object, weight of stone can be easily identified by differentiating these two things. So that the apparent loss of weight of stone is nothing but what? It is equal to, then afterwards take it to spring balance or else calculate the weight of water displaced also. The apparent loss of weight of the stone is immersed stone is equal to what? Weight of water displaced by the stone. Water is displacing by the stone or not there itself. As we are immersing stone into the water is displacing by means of what force? Buoyant force. By means of buoyant force acting upon the particular object, allowing water to fall outside and to reduce its weight. Therefore, the apparent loss of weight of an object, that is nothing but what your object is what? Stone, is equal to weight of the water displaced by that particular stone. Not only that, but it is also equal to force of buoyancy or buoyancy force exerted by water. By water, there is exerting buoyancy force on this object as it is immersing. See here, as the object is immersed inside, there is exerting buoyancy force on the surface of this particular object. The force of buoyancy exerted by the water. What is exerting the force? Due to that reason, the body is moving a little bit upward direction. Due to that reason, W1 weight is not equal to W2 grams. There will be variation. W1 gram is having more weight than W2 grams. How much weight has been get lost? To identify that one, I am differentiating these two things. That is W1 minus W2, which will give us loss of weight of apparent mass of the stone when it is immersed in liquid. Why it is losing its weight? Due to acting of upward thrust. due to acting of upward thrust or force of buoyancy exerting by water on object. Due to that reason, the body is losing weight. Based upon this particular principle only, Archimedes, when he is working under a king, when king has given a crown to him to identify whether this crown is pure or not. Pure, the gold, how much gold he has given, with that gold, this particular crown is made up of or not, he want to identify that particular one there. That by performing this experiment only, as he want to take a bath within a tub which is fully filled up with water, as he is thinking about this thing and as he entered into the particular tub, what happened there? The overflow of water has been taken place. Then he got an idea and he said that Eureka, I got it up. And he, by using that particular, when an object is immersed in water, which is completely filled up with water, overflow up to completely full, if it is filled up with water, if you are sleeping, if you are entering, if I am throwing any object into that one, the water will be get overflowed. Based upon that principle, he calculated density of gold as well as density of crown, and by which that particular person prepared that particular water and a crown what he has prepared there itself. Then he identified clearly that density of gold is much more greater than that of density of water. In that particular way, he testified clearly that it is gold, how much gold the king has been given, the same amount of gold he did not utilize in manufacturing, in preparation of that particular crown. Based upon this particular formula, that is Archimedes principle. This Archimedes principle can also be had applications, same as buoyant force application only, submarine it can be useful. Simultaneously, it can also be useful for what? Hot air balloon. Fishes, they can also use this particular Archimedes principle. Ships, which are floating on the surface of that particular water, will have what? The same thing there itself. Which can also have what? These four are nothing but what? Applications of Archimedes principle, same as buoyant force. By this, we have completed our activity, children. Try to analyze this particular activity and gain knowledge. Thank you, children.